So let's kick it off.
Yep, I'd just like to do an acknowledgement of country. I'd like to acknowledge that we meet on the lands of the Ghana people and we pay our respects to elders past, present and emerging.
Thanks, Ben. And today I'll introduce our presenters. So we've got two for one special today. First up, we'll have Knut Menden of Betti and Knut. Knut draws on more than 20 years of experience as an architect in award-winning sustainable architecture with a European background and an in-depth knowledge of sustainability and energy-efficient designs, along with experience in different climates from different countries, including Germany, Luxembourg, Austria, New Zealand, and Australia. He runs an architectural studio based in Coledale, New South Wales, together with his partner, Interior Architect Bettina Steffens, minimizing architecture's impact on the natural environment with very low energy use as a pathway to creating sustainable and healthy living and working environments is at the center of the practice's core values. And we'll also be hearing from Russell Kilmartin, Director of Scientific Fire Services. Russell is an experienced professional in the field of fire safety risk engineering for both private and public sector clients for over 20 years. I hope you've all had a chance to read Russell's bio because he's a very impressive guy and he's got a huge amount of experience. In more recent years, Russell has worked on some of Australia's most innovative timber buildings and successfully presented large-scale timber building designs to building authorities and the fire brigades in Victoria, New South Wales and Queensland, with a very long list of examples in the industry. So please check out the bio if you want to have a look. Russell and the team at Scientific Fire Services have been privileged to work with industry-leading architects, designers and experts in mass timber technologies and are passionate about ensuring that structural timber is appropriately adapted within the modern construction landscape. So please take it away, Knut.
All right, thanks for the introduction and thanks for having me. All right, okay, so so the focus of this presentation is CLT or mass timber in education projects, which we've been working on some projects, and I'm going to use one project as a case study and another project just to lead into Russell's part for the fire engineering, because I mean, my understanding was mainly that I've been talking to Simon, who sort of invited us into this. We're just doing a house with him on Kangaroo Island in CLT. It's a residential house, Passivhaus as well. And I think there was a bit concern from architects in general about using CLT, particularly in combination or with thoughts about fire and CLT. And so just very briefly, myself and my partner, Bettina Steffens, we are just a small company in Coledale. All we do is CLT buildings, really, and that's different scales, mainly residential and education projects. And why do we use mass timber to start with? I mean, there are lots of reasons, and I think one of the big ones is the quality of the finished product that you're getting when you're using mass timber, because it's prefabricated, it's built, pre-installed in a controlled environment. You've got the speed of construction on site, and with that cost reduction, because obviously labor is expensive. Obviously health and psychological benefits of timber. There's the buzzword biophilic design, which I don't like to use that often, but sometimes people can relate better to this. But there's lots of research about the psychological effects of using timber in buildings on human beings, which I think are really valid points. It's the only renewable building product. Obviously, we like the look of it. We like the way that buildings are put together and the structure and the way that it works. And then there's the sustainability of the construction. So on one side, on the energy efficiency, because you've got at least 100 mil thick timber panel as your main structure, which is very different to having a 150 mil thick piece of concrete as your structure. And then there's the reduction of CO2 emissions to start with, and which I think is one of the main reasons why we have as a default to use CLT to reduce the impact on the environment. This project here, Our Lady of the Assumption, is a primary school that I worked on when I was still at BVN. And that was I think it was Australia's first CLT school. This is not a Passivhaus project, which is the other part that we usually use in our work, but it was one of the first CLT. The project is using an existing building. It's an old Telstra building from the 1970s, and the Catholic Education Office bought this building and thought they could just turn it into a new innovative primary school, which we did in the end, but not in the way that the client originally anticipated, with just doing a refurbishment or fit out. This is sort of the final project. It's a very small site. As you can see, very constrained for a school from going from K to year 6. So we used some of the roof space for playgrounds and for sports fields, and we built on top of the existing structure and extended it with a new hall, all in mass timber. And this is the building which they purchased. So it's actually a very grim building. You could make probably quite a cool apartment building if it was in a different area and it was not a primary school, but it was not the best start to start a new primary school. I'll show some photos of the finished project. So this is the project under the area where you see the yellow and orange lines in the window reveals. That's the old building, the old concrete building. And we've essentially built a new level on top, 2 floors on top, extended with a 4-story atrium and a new hall and external classrooms on the left side where you can see the car in front of the building. And so the outside is a zinc facade with some custom perforations and some play with words from their logos and visions. And internally, it's all exposed timber as much as we could. So there's only some parts, and that is mainly the atrium, where we had to enclose the CLT because we've got a 4-story atrium here. But as you can see, we have a stair here which runs through the entire atrium. It's an open atrium. The stair is using the CLT as the structure, so there's no additional steel. That stair that you can see on the right cantilevers to a portion, to quite a bit of a portion, without actually just the part that you can't see, which is at the bottom. And we've used timber throughout, so also the ceilings. I'm going to go into quite a bit of detail for the ceiling here. There's an acoustic timber ceiling here, which is part of the prefabricated system, which had a huge impact on this project. This is the top floor of the building. This is within the existing building, so we've used similar materials. We've used the same acoustic timber ceiling to follow through with the design language within the building, although this was in the existing concrete building. This is one of the features which I was always anticipating that it would disappear at some point, because someone would say, no, we can't do this, but we actually built this quite large, I think about 6 by 6 meter reading net over a 2-story atrium where the kids can hang out and read. And that's the hall of the school, which was on the other side of the existing building. We've got an 18-meter span with those timber beams here. As you can see, they're spliced in the middle with a very, very neat detail. And I'm going to show more of that later as well. Going through the different parts. So as I mentioned, I'm just going through the render just to show it's build up. Obviously, the external part of the building. So internally, we have the gray bit is the existing Telstra building. Then all of the glulam timber columns and beams, which we've used a very interesting connection system from Switzerland, from Neue Holzbau AG. And we even have moment-resisting connections on the top part of the roof, which if you talk to a lot of people in this industry say it's not possible in timber, but it is if you've got the right products. All the walls are CLT, so cross-laminated timber. And then our ceilings or slabs are a system which is a cross-laminated timber system, but with prefabricated acoustic ceilings as well, which comes from a German company called Trend, which was a huge part of getting this project over the line, mainly for cost reasons. But I'll go into that a little bit later. So looking at the existing part, this was a very complex project and probably not the easiest to showcase the benefits of, it would still showcase the benefits of mass timber construction, but this was a very complex project because of the existing project. So you start with a building from the 1970s, which had columns, obviously concrete columns, which were 30 mil, 50 mil off. Anyway, there was a grid there, but the grid, obviously, if you look at it in detail, it's not the perfect millimeter construction, obviously, because it's in situ concrete. But the timber structure comes in with a 2 millimeter tolerance. So you have a very precise building that's put over the top. So what we had to do to start with was essentially take a 3D point cloud survey of the top floor to see where exactly all those columns and existing beams that we were keeping are located, so that you could then use that as the basis for your 3D model for the timber structure. So we got this 3D point cloud survey done, which had about 10 gigabyte because it picks up every square millimeter, which was essentially more or less unusable because it was so large you couldn't open it with any computer program. So what we did there was we just always used the areas where we had a connection as the real 3D point cloud survey, and the rest was just modeled generally. Looking at the glulam portal frames, beams, and posts, just going into some details. So as I mentioned, we've used Neue Holzbau AG, which is a Swiss company. They have a very good system of connections. So they've got glue laminated threaded steel rods that are essentially integrated into the timber, which is great for fire performance because none of that timber is exposed. And then these elements go together really easily. I'm going to show you one of these, for example. These are the top floor columns and beams. So as you can see on the left side, the product as it's installed, as it's fabricated, and on the right side when it was installed on site. So there are two nuts that needed to be fixed to get this connection going. So in general, what we know from all the installations is it takes about 15 minutes to install any timber element, whether it's a column or a beam or a slab. That way you can actually predict pretty well also how quickly the building will be put together. What you can see here is the hall. You can see the guy there on the left side. He's just hammering in 5 bolts, and that's it to connect these 18-meter, about, I think, 900 high beams for the hall. It's a bit more of a detail here. Again, very strong connections and very safe connections because they're fully embedded in the timber. So as you can see on the left side, those holes will then be plugged with timber and rock wool so that you have also the protection of that little bit of steel that is otherwise exposed. And it's a very fast way of installing it because, there's some of the connections you have lots of screws and that will take some time, but these ones are a very, very efficient way of installing this. And you've got the continuation in the beams. A little bit of what you can see here is the ceiling. This is actually a photo from the site on the day that it was installed. So that was one of the reasons why with the Lignode Trend CLT slab system, we were able to convince a builder who won the job on the cheapest price and thought they could convince the client to go traditional and do it all in concrete and steel. And we had to run through a whole value engineering process. And at the end of that value engineering process, we were still there with the same solution, which was quite an amazing outcome, considering that the builder had no interest in building this in timber because they didn't know about it. You can see also on this beam connection, you don't see anything in terms of connections because these beams, the 9.5 meter long beams, they had the, as you can see on the top left side, they had the brackets installed in the timber. They were moved in from the top, and then there are, I think, just 2 screws that are fixed from the top. Again, once you put the CLT slab on top of that, this piece of steel is fully encapsulated within the timber. So that means, again, it is safe from fire in its first instance. Also, what you can see is there's very little people on site. So these guys have been running the project about, I think it was about 3.5 to 4,000 square meters. They've been running the timber structure with 6 people, with a team of 6 people. And in an ideal world, they would just come to site, do their job, finish it, leave it, and then the builder comes back in and continues. I think that's one of the key lessons that we've learned over the years. If you've got a good team of CLT installers who know what they're doing, and you've got a good head contractor who knows how to plan things and follow on with the other trades, that's the key to a good mass timber project. Yeah, you just see a bit of the roof structure here. They did about 500 square meters a day of the slabs to finish that off. Walls, as is mentioned, we're just using cross-laminated timber, so there are some smaller elements, as you can see on the left. Then some of the elements where they were harder to reach with the crane, they're actually pre-assembled, like this corner there, and then craned this corner into place and fixed it. And then we've got other areas like here where we're using double height. So these timber panels on the left side in the hall, again, they're going over 2 stories because obviously, so we are often using CLT from overseas, from Austria for lots of reasons. And then you are a bit restricted with the size due to the container size. So 2.25 meters is a sort of is a good width for any panel, but you can go up to 11.5 meters long. So we're trying to make the most of it. In this case, that's why the panels are used vertically rather than horizontally and going over 2 stories. And on the right side, you can see how the stair was installed. So first of all of the balustrades were installed, which are the main structure of the stair, and then the treads were added in. That's a view of what was later then the reading net. And then coming to the slabs. So the slabs in this case were crucial because, so generally we would use a solid CLT slab and we've got our floor built up and we've got our ceiling below. With a school, acoustics are really important, obviously. And that's why an acoustic ceiling is a must. So there was no way of actually exposing the CLT as such to, to just get the acoustics going and within the spaces. So this company I came across, I can't actually remember how, but it's a German company called Knut Menden, and they sort of started 25 years ago and said, look, if we have a solid CLT slab, maybe we can do more with that than just having a solid slab. And they started to think about what can we take away from this solid slab, what are we left with, and what can we gain from this. So they developed essentially this as a cross section, which is still a cross-laminated timber product, but mainly working on the absolute minimum of what we need. So you've got the structurally necessary CLT, which is obviously necessary for your structure. And each project has different sizes. So this is a very small size of those panels there. It depends on the spans, etc. And then you're left with the services zone. So that means in this zone, you can install electrical conduits. We've also installed the sprinkler pipes in this zone. Then you've got your additional layers, and that depends on what you need. For example, in our project, generally, you've got a 120-minute fire rating for a school project of type A construction, which with fire engineering, we've been able to get down to 90 minutes. And that means this area here is the part where we increase the thickness of the CLT to achieve the 90-minute fire resistance. And that's mainly done by the charring. And then you've got your finish. So it could just be just a plain CLT finish, or it can be an acoustic ceiling. And this is what saved us the cost, because the additional cost of having that actually very beautiful timber acoustic ceiling there was sitting at the time at around $30 a square meter as additional costs. If we had taken this as a suspended acoustic ceiling, the same ceiling, and installed it on site, it would have cost us $220 a square meter. And that cost saving was, I think, one of the key reasons why the builder was unable to get this to work any other way, because even with the cheapest concrete and steel structure, they wouldn't have been able to meet that costs with that price difference. And again, this is coming to the point as if you can do as much as possible within the prefabrication part, that's where you really gain the benefits in mass timber. Again, so this is how the slabs were installed. You have to be obviously a bit careful and think carefully about how you actually lift them in place, because you can't just put a sling underneath, because you're going to ruin the underside, and also it's harder to get it in place then. So there's an interesting system that the installer came up with to lift those panels in place. And then these are all so they're essentially lowered down onto the beams. And then with any type of CLT slab, or whether it's this system or another one, you still have to get them close together. So you see the ratchet at the front there. So that's how you sort of get the last centimeter from one panel to get them really tight against each other. And then there's lots of screws, fasteners to go in there, usually about 280 to 350 mil long, every 300 mil. And that's how the whole structure is put together. So it's on site. It's very interesting because it's a very, very clean site generally. I mean, this one was a bit different because we had demolition there and we had an existing building, but generally a CLT or mass timber site is very clean and also very quiet actually, and not that many people around. So this shows the system here, that how it's then getting installed. So you have all your services that you want to run in those areas. And then the leftover space is filled with an aggregate. And this is mainly for acoustics, to get a better acoustics out of the floor, because otherwise you're obviously left with hollow spaces. With the mass of the aggregate, you get a good acoustic separation between the levels. Again, this is a photo from the day it was installed. So you've got really a beautiful, perfect ceiling there. And just some other photos from the roof installation. So the roof slabs are not open at the top because you're not running the services there. And also it is for keeping obviously the weather out of the building. So you've got a closed top for the roof panels. This would be more like a traditional CLT panel. And that's very short time lapse. Sort of shortened it a little bit just to show that part of the installation. You can see how the beams were installed, how the slabs went up. Sorry, this is a bit loud, but music. Anyway. I think key, as I mentioned, is the installation, is the follow-on trades to get this whole thing waterproof. This is really loud. Okay, I'll wait until its music's finished. You can also see the build-up on the roof up there. Generally, this was not built as a passive house, but it was installed in similar ways. So we've got our insulation on the outside, obviously, and then we've got our waterproofing membrane and the same build-up for the walls. Sorry, now. This is just a little comparison that I usually like to put up with all of our projects, just looking at how much CO2 has been stored in the project. So in this project, we've stored about 1,400 tons of CO2 in the project's mass timber. If that would have been built traditionally, we would have emitted 800 tons of CO2. So a very different perspective there. And that means essentially we've taken 490 cars off the road for a whole year. And all of the timber that's been used in this project is regrown in 23 minutes. So that's the regrowth rate of timber from where the timber was coming from. And so just to lead into Russell's presentation, we just wanted to quickly show the project that we're currently working. This is the Illawarra Grammar School. This is going to be Australia's first CLT Passivhaus school. So another step further. So that's that's a project that we've just sent out for tender. So that's currently out in the market. Two-story building. As you can see here, it's got a huge green roof with music against so loud. So I don't know how to change this. There. Okay, much better. Two-story building. We've got a timber facade in this case, which was great. So Russell has been able to justify that in the fire engineering. We've got the main two-story entry, again with the CLTs there, exposed CLT. We're exposing as much as we can. Again, we've got an acoustic ceiling. Classrooms on the ground floor, we've got junior school classrooms. So there's a home base, then there's a withdrawal space in between. And then we move back into the central practical activity area. On the upper floor, we've got the senior school. Just turning a bit around. Senior school with 7 classrooms. We've got, actually, we also have a junior library on the ground floor. And then we've got a large or mid-size 150-seat auditorium on this upper floor. Again, all exposed CLT. We've got our acoustic timber ceilings in place. So that's a really neat project that's hopefully gonna get built in January next year. And just some more images of that. And then I'll leave it up to you, Russell, to talk about fire in those cases. Oh, sorry, just quickly. Comparison. Again, it's a bit smaller than OLA, about 800 tons of CO2 saved in the timber, stored in the timber, 380 tons avoided, about 240 cars off the road, and the whole timber here is regrown in 13 minutes, which I think, is always a nice statistic. And leave it to Russell to continue.
I'll bang through this as quick as I can. So from a fire engineering perspective, timber and fire, you would think they don't match, but that's probably certainly a myth. It's been our experience with our involvement with mass timber in buildings and global research that in fact it's a wonderful product with respect to fire. If it's developed from a design point of view and installed properly, it can be a wonderful material and they can cohabitate. So in 2016, the Building Code of Australia, and I'm probably telling architects here things you already know, but in 2016, the Building Code of Australia allowed mass timber to be, it actually codified mass timber and brought it into the code. And as after a lot of lobbying from Timber Development Council and other authorities around the country, and it allowed residential buildings and office buildings only. And then in 2019, the BCA expanded that to all buildings, including education buildings, schools, etc. Following, not within Australia, but in 2021, the International Building Code introduced 17 changes with regard to mass timber, and I'll go through those shortly as well. So there's been an uptake in building codes ever so slowly to allow mass timber in the building codes. Whilst it's relatively new technology, people have been building with timber for centuries, for millennia. It's now been codified in many codes around Australia, but we're talking about Australia here. And approval authorities and regulators, they traditionally like to follow code conformance, and where we don't follow code conformance, that's probably where fire engineers get involved with projects. So So what have we seen since 2016 and 2019 changes? Our office has been fortunate enough to work on a few projects. Starting in 2011, there was a Forte apartment building in Docklands in Melbourne. It was a 9-story building. Then we see an assembly building, which is a library building in 2014, mid to high rise office building in Brisbane, which was predominantly exposed mass timber, student accommodation, Latrobe Uni. I've highlighted these dates red because they are all post 2019 building code. So it was, and certainly our office is not the barometer of timber at all. This is just our experience, but pre-2019 with 3 or 4 or 5 projects, post-2019, all of a sudden the uptake of timber in buildings, in different types of buildings, shone through. So, you know, this is an education building, this is a hotel, 10-story timber structure on an existing 7-story concrete podium. Another hotel in Sydney, CLT predominantly, an entertainment venue in Sutherland in Sydney, shopping centre, community centre. This is Wellington Street, Collingwood, which is a mid to high rise office building in Collingwood, Geelong, Surrey Hills in Sydney, et cetera, et cetera. So another primary school there. So the uptake has been good to see, not without its challenges, but certainly considerable. With regard to fire brigades, and you'd be dealing with fire brigades regularly in submissions with any project, the fire brigades have put out a guideline. An AFAC is the Australasian Fire Authorities Council, so that's all the fire brigades around the country. They've put a guideline together. They're changing it up now. They're reviewing it and watering it down a little bit, but it's good evidence to demonstrate that the fire authorities haven't got their head in the sand. They're stakeholders in the built environment, so they've put some guidelines around designing and constructing mass timber so that designers take into consideration their concerns. So that's been good to see. The current limitations of mass timber gets forgotten a bit. So the prescriptive codes allow mass timber to be in buildings as fire protected timber. That means fully encapsulated, can't build more than 25 metres in height. There's encapsulation rules, 1 or 2 layers of fire-rated plasterboard. And so if you're wanting to express timber as an architectural aesthetic element, the building code hasn't really done you any favours. However, if you're purely looking at from a sustainability point of view and seeing the timber is not critical, then you know that's a good step. So the obvious issue, I'll go back, is nobody wants to see pink plasterboard and painted walls when you've gone to the effort to put timber in a building. Certainly you want to express that. So just going forward with some of the challenges that we've seen, the code expansion is actually, it's been terrific because it's been based on engineering science, engineering research. And so the flow on effect has been quite considerable. I suppose I'm showing my age a little bit here, but in the 80s and 90s, I was privileged enough to see a lot of the testing experiments, and that's that bottom image there. It may not look like anything, but that was BHP's test facility for burning open deck car parks with non-protected steel. And they spent millions of dollars back then to undertake this type of testing, and they got their wish, and unprotected steel was codified, was brought into the code, and is allowed in certain circumstances. So there was an investment by industry to change the code to allow non-protected steel, and that's happening now with timber. And there's a lot of research going on globally and also in Australia. And if I look at it globally at the moment, and this all relates back to any building, including education buildings, this is what's happening in North America, the International Building Code. So they've just introduced in 2021 a raft of prescriptive code compliance allowances, I suppose, for want of a better word. You can see this one here on the right. It allows in their code, under certain circumstances with certain sprinkler provisions, building a building up to 9 stories, fully exposing the timber, no encapsulation required at all. There are calculations in science and engineering that needs to justify the design, obviously, structural being the obvious one. And then as we go higher, we see some 12 stories, limited exposed timber, more testing required. And then we get up to 18 stories, which is a fully encapsulated timber structure with some parameters around that as well. So as you can see, there's a global acknowledgement that designers and community want to see timber, but you can also see as we go up size and scale, that risk increases, and therefore other measures are necessary. What I like to express whenever I'm presenting any particular project with timber is it's not just the structural element. The structure's not that too difficult to imagine, particularly with a good structural engineer and good architect. The structure's one part of it, but it's occupant life safety as well. So where a building has a lot of timber exposed, then we need to demonstrate whether it's a safe environment for occupants. Have they got time to evacuate the building? Have they got time to safely reach the fire stairs? Similarly with brigade, depending on the state, they have a call out time that they try to adhere to. We need to demonstrate that a building, when the brigade arrive, they've got adequate firefighting equipment, but also will that equipment be enough to actually be able to suppress a fire if all of the timber becomes involved in the fire? And there's an engineering principle behind that as well. Internal fire spread, external fire spread. These are elements that are important. Knut was showing an atrium in a building. It's not, the building that he showed wasn't 20-story building. It's a low rise, so it's less consequence. But you can imagine a building with an interconnected atrium portion up high in a building, that if a fire was to get away from the systems in the building, then it becomes a bigger challenge for the brigade. So there's a lot more than just the structure and structural integrity. So I guess this slide was something I presented to another conference, which is more talking about changing the codes and is there a future risk without code change? I believe there is. I think going back to this circumstance provides some structure and guidance for designers. Without it, you're delving into the unknown and potentially some unsafe design. So, but the code prescription provides a structure. So if the Timber Development Council and other lobby groups can continue to lobby the Australian Building Codes Board, then there's going to be more structure around timber from a design point of view, which is only a good thing. So what does everyone want to see? Well, what architects want to see, what everyone wants to see is timber, timber, timber always. Every project I've been involved in, it's can we expose the timber? And the answer is under most circumstances, yes. Under some circumstances, definitely not. And that's where the fire engineering comes into the project. We've got, this is inside a fire stair, this second from the left, exposed timber in a commercial office building. This is there's some feet and some exposed timber in this commercial office building, and that's an actual fire stair in a hotel behind a fire-rated glass wall with trenches. So there's a whole myriad of circumstances where timber can and cannot be exposed. I do get a little bit nervous about when we start putting holes in floors and connecting floors that have exposed timber. This is King Street, Sydney, Brisbane. This is exposed timber throughout most of the building and an interconnecting stair in an office building. So in this case, it's surrounded by heat strength and toughened glass and wall wetting sprinklers to mitigate fire spread between two levels. There is a bit of a lack of knowledge and understanding for building surveyors and fire engineers on timber, but that's growing. And as I said, only code changes will assist with that. I won't speak you with these next two slides too much, but in large, complex, multi-story buildings, there is a requirement for justification of testing, and sometimes that is the connections themselves. Those connections that Knut showed of, I think they've been codified in Eurocode or likely to have been codified in Eurocode. So that evidence can be used to support their use, but where they haven't, and it's a critical element, there's testing required, or potentially finite element analysis modeling as well. And here's a good example. That's a beam and column connection that was tested for 2 hours in a furnace. Once it was taken out of the furnace, I don't think they extinguished it. They let it self-extinguish, tested under load. So the actual load of that building, that's how it was tested, structurally loaded. And it satisfied its 2-hour requirement, including the connection and the joint where those connections are embedded. So So there is a lot of testing and research out there. So for education buildings, particularly school buildings where they are 1 or 2 story, I wouldn't see this type of testing to be necessary, particularly a single story building. You can build a single story building essentially type C construction, and timber is a perfectly acceptable solution. Once you start going up in levels, the 2-story building become type B, which is a peculiar recipe for construction. I've always found it. Columns are required to be fire rated, but in some circumstances floors aren't. This type of testing is really complex buildings. So look, we're nearly there. The next slide is probably one of my favorite photos. I think this is the old Maya building in Hobart that burned to the ground a few decades ago. If you see this, what looks like wire hanging here, this is the old style steel within the concrete. So there was a concrete floor here. It's gone, burnt and collapsed and totally gone. You can see these main primary steel members. I'm not sure whether they're roof members or floor members. And you can see this mangy, prickly old piece of material here. That's the timber beam. So once the building burnt to the ground, the only thing standing was the timber, still holding up the steel. I wouldn't say it's holding much up, but I just like it's a great photo to highlight that, yes, it burns, but it self-protects itself. Timber has a wonderful ability to be able to protect itself by that outer charring layer, and those structural, the structural performance of material of timber actually can be quantified quite easily. Last slide. So just in summary, what I'd certainly like to see and what I think the industry likes to see. So I'm not quite sure how far they've gone down the path, but codifying carbon emissions for timber would be a great positive outcome, because once you codify something, it's further entrenched, obviously, in the building code. But if you can codify the carbon emission reductions, even better. Codify sustainability objectives of timber. I'm sure this work is going on behind the scenes. It's not my area of expertise, but if these things can occur, unfortunately for architects, you'll probably end up having another consultant on a job that you've got to deal with. And I don't know how you do it, because you're dealing with, every time the code changes, there's a new breed of consultant. But this area, I think, is important. But changing the code and bringing timber into the code and allowing us to design increases the approvals confidence, speeds up the approval process, and decreases the uncertainty. Look, it's not, the presentation's not specifically targeted at education buildings, but having said that, most of the buildings we've been involved with from education point of view have been low rise, which means they're relatively low risk. As long as the egress provisions are sound, then occupants merely evacuate the building. I'm not suggesting you leave the building to burn to the ground. New South Wales Fire Brigade, they like sprinklers in all of their buildings that have timber in it. South Australian Fire Brigade, we've found to be they're professional. They're conservative by nature, but that's they need to be. They're quite professional and open about it. Single story building structures, I don't think there's any issue with timber. You can timber everywhere. It's when you start putting multiple stories with particularly atriums and open stairs where it becomes a bit of a challenge. But there are systems and ways of dealing with that. So yeah, we come into that game when it becomes a little bit difficult to comply with a prescriptive provision. So I'll leave it at that. Thanks for having us. Thanks for your time.
Thanks, Russell and Knut.
Yeah, thank you so much. That was amazing.
Yeah, it was really informative. Ken, I think you're the only one with a question today.
Of course, it's a really interesting one when we were talking about like value management and how timber gets properly value is evaluated, right? So I was a little bit more interested in like how, like, who did you need to have make sure you had on board, like in the project team, to make sure you guys were advocating, like actually bringing like the cost, not just of like the materials, but then also like through construction, everything like that, especially if you had like builder pushback.
Yeah, it was very interesting. I think the key which I found over the years is to have that direct contact with the actual supplier and installers and have that lined up and fully understand that their requirements and how that works and how you can get the most out of it. We do on our residential houses, we do, as I said, we do everything in CLT. We have a team, we've got about 2 or 3 companies who we generally use to install the CLT, and we get them to be part of the tender. And we do the same on the education project. So for this project that I showed last, we've essentially nominated the installer, we've nominated the timber products, we've nominated the connections, and that's all going into the tender package. And then we get to a head contractor and get the head contractor to obviously supply the full building, but they have the obligation to use these subcontractors for that part. And that's the way that we de-risk the project, and not only for the client, because obviously we get their quotes early on. We know what the cost is of the CLT and of the mass timber. We know what the installation costs are, but also for the builder, because if you've got a new builder, a new head contractor, and they haven't done that before, they would otherwise get quite nervous and add a whole lot of risk percentages on top of that. And I think this was key for most projects, and I think particularly for commercial projects. If you can put the head contractor at ease and say, look, you've got the expert here, they know what they're doing, you've got the costs, you can just use their costing for your tender, and you deal with everything else. That's, I think, a big thing. And with the OLA project, that was the case where it was very interesting, because the original cost came back more or less in budget. I think it was an $18 million project, and the quotes came in between 17.5 and 19. But at that time, the client decided they wanted to strip out another 1.5 million from the project. It was very interesting, because at that point we've dealt with the client directly as architects. At that point, an external project manager was brought in to just deal with value engineering, which for me felt like this is the worst nightmare. You get someone in who can trash the whole project, get the cost that they want, and then leave, and we're left with the pieces. But because we've been working directly with the suppliers and the installers, we've been able to cut down the costs on the timber wherever we could, and that was a big difference. The other thing to keep in mind is, with the standard knowledge that you get out of structural engineers in Australia, with, I'd say, a bit more limited experience on large timber projects, is they would go very conservative and have very large columns and very large beams. So when we worked with Neue Holz as that second step, our columns and beams were about 320 wide, that were all reduced to 240 and 260 in width. So there was about a 30% reduction in the timber, just because as a standard, these connections, the structural engineer would just use very, very standard connections, and then you've got different loads, and then therefore you have to increase everything. So that was a really interesting experience. And yeah, as I said, the builder wasn't interested really in doing it in timber. They were more interested in getting the price down. And we've been going for a month of value engineering. They came up with the next idea, and we've all the way along been able to show that the timber was the cheapest option, which was a great outcome. To go back on, as I mentioned, we have only one residential project which we've just finished building in timber frame, because we just couldn't get the crane in to install the CLT because of power lines on the road, and that came actually in slightly more expensive than the CLT option that we had before. I was thinking maybe we get it a little bit cheaper, maybe same price. I was more thinking same price, but I thought it was interesting as an experience. But that came in more or less the same price, just a little bit more expensive in the timber frame than in the CLT option.
Excellent, thank you. Great presentation, guys. Quick question for Knut. Using the Strathfield example, was all of that timber brought in from offshore, or was there a mixture of some that was locally produced? Assuming it is offshore,
Yep.
Do you see potential in the Australian manufacturing sector of CLT to be able to cope with that sometime soon, to cut down on the carbon miles?
Yeah, so so all of that was brought in offshore. I have to say also that project was done before 2019, before the 2019 code change. And at that time, XLAM had just started they were just starting their production at that time, I'm pretty sure. When we were tendering for the project, they were not in production yet. Obviously, there's now XLAM in Australia, which do radiata pine CLT panels. Then there's Next Timber, which I think has just started about probably half a year ago with production in South Australia, as far as I understand. I think Next Timber would be something that I'm looking at closely, because that might be a good alternative to overseas products. And I'm saying that because one of the reasons why we use overseas CLT, in this case we generally use KLH from Austria, is the costs are lower, the lead time is interestingly, the lead time is faster. So we get them here faster than getting them locally sourced. They've got more prefabrication capabilities, so you can do things that at the moment, and that's why I think that's why I hope that Next Timber is going that way in terms of the prefabrication to the panels that you can do. They've got better capabilities there, and then you've got also different types of qualities in the surface quality of the product. So these are for us always the reasons why we go that route. But I think, yeah, the South Australian plant, that could be a really interesting one. And then just quickly on the carbon emissions, just to keep in mind, the carbon emissions from shipping a container 24,000 kilometers on sea on a big, large vessel is the same as trucking it 500 kilometers over land. So I think that's just something to keep in mind. And for example, Lignotrend, this company that we've used for the ceilings, they source all their timber within a 50-kilometer radius around their factory. If you look at the Australian factories, they've got a range, I think, from something between 800 to 1,000 kilometers around their factory where they source their timber from. So that's only getting it to the factory and then, then manufacturing. So I think if we take those things into effect, I haven't done any detailed calculations, but I think at the least they would be equal.
That's really interesting.
Can I just interject quickly? It is actually, I've seen the calcs, it is actually more environmentally friendly or less carbon intensive to source timber from overseas, but also our timber industry is not that great at the moment. We're not very good at planting trees. So yeah, I would suggest sourcing it from overseas is actually a better option.
I have to say I agree in terms of also, because what we haven't touched on is how are these timber forested and planted and harvested. And what I can see around Australia is whole landscapes are getting raided when they're getting harvested, which means everything that was in that forest is getting destroyed. There's nothing left in that forest. Whereas in at least the middle Central European countries, trees are taken out of plantations as they are ready to get taken out, and it's not a whole blanket culling
Thanks
of
for
trees.
that. Well, thank you both very much. I think we've probably hit our time limit. It was really interesting, and I hope everyone starts pushing more for CLT because it's a really great product, and I'd like to see more of it everywhere.
Yeah, we can see how beautiful your little studio is as well. So, warm and friendly and inviting. So,
Yeah.
a beautiful environment to be in.
It is, yeah.
Fantastic. Thank you both. We really appreciate
Pleasure.
it.
Thank you all. Cheers, Knut.
Thank you.
Thanks, guys.